Hello students, welcome back to my channel. So how are you all students? How are you preparing for your exams? I think mostly in the next month you will be writing your semester exams, right students? Okay, so today's video I am going to explain Arrhenius theory of electrolytic dissociation. You know students, under which lesson is this topic? Yes, it is under electrochemistry, which is in semester 4 of B.Sc second year. Okay students, hope this video helps you. Okay, without any delay, shall we start students? Yes. So, what do we learn under this Arrhenius theory of electrolytic dissociation? First of all, we should know what electrolytes are. Okay, so these are the substances which can conduct electricity in fused state or when they are dissolved in polar solvents like water. We call these substances as electrolytes, students. Okay, so the first I mentioned the definition of electrolytes. The substances which can conduct electricity in fused state or when dissolved in polar solvents like water are called as electrolytes. So why did Arrhenius propose this theory of electrolytic dissociation? He wanted to explain the behavior of electrolytes, students. So this is the reason why he has put forward the theory of electrolytic dissociation, that is dissociation of electrolytes in solution. Okay, so if we look into the main points of this theory, there are some 5 to 6 main points in this theory, students. One after the other, we will try to understand the points of Arrhenius theory of electrolytic dissociation. Okay, so the first point you can see, they can dissociate into positive and negatively charged particles in solution. That means suppose you take an electrolyte and try to dissolve it in water, students. So the electrolyte will be dissociating. That means it will be parted into positive and negative particles. What are these positive and negative particles? Particles here, I mean the particles means ions, students. Okay, so electrolyte, when it is dissolved or when you add some water to an electrolyte, it will be dissociating into two types of particles. What are they? Positive and negative particles or positive and negative ions in solution. So don't forget to write solution, students. Okay, now what do we call these positive ions and negative ions, students? Positively charged ions or positively charged particles, as you all know, we call them as cations, and negatively charged particles or negatively charged ions are called as anions. Okay, this is the first point under Arrhenius theory of electrolytic dissociation, students. Okay, so hope you understood first point. Yes, an electrolyte in solution dissociates into cations and anions. I have given few examples here, students. First one is NaCl. You know, NaCl in solution dissociates into two ions, positive and negative ions. What is the positive one? Na plus, and the negative one is Cl minus. So NaCl dissociates into Na plus plus Cl minus. Second one is NaOH, students. NaOH dissociates into Na plus and OH minus. KCl dissociates into K plus and Cl minus. Okay, so this is the first point and you can quote few examples under the first point, students. Next, second point, students. What happens when an electrolyte is in solution? You know, some of the electrolyte might dissociate into positive and negative ions, and some part of it remains unionized, that means or undissociated. Okay, so in such cases what happens, you know, students, we find an equilibrium existing between the dissociated ions and the undissociated molecules. So that is the second point under Arrhenius theory of electrolytic dissociation. What do we write, students? There exists an equilibrium between ions and the undissociated part of the electrolyte or undissociated molecules. So I have mentioned here NaOH gives Na plus and OH minus. So this is the sign of equilibrium, students. So these are the dissociated ions and some part of the undissociated sodium hydroxide. So this portion and this portion, there exists an equilibrium between these two. Third point, when once the electrolyte is dissociated into ions, now the ions are free to move towards the opposite electrodes. When these ions will be able to move towards opposite electrode, students, under the influence of that means only when you subject it to electric field or when you apply the electric field, then the dissociated ions will be moving towards the opposite electrodes. Positive ions towards negative electrode and negative ions towards positive electrode. Okay, that is the third point. Next, fourth point, the degree of dissociation increases with the dilution. You know what's dilution, students? Yes, adding of the solvent or adding water. So the concentrated solution, or when you are adding the water, it becomes diluted. So on dilution, what happens? The degree of dissociation increases. That means what? The number of ions will be increasing on dilution, and at infinite dilution, what is infinite dilution? At the maximum level of the dilution. That means after this point, there is no part of the undissociated electrolyte. So at this infinite dilution, we can say that dissociation is 100% complete. Okay, very easy to understand now, students, and this is also highly interesting, this topic. So fourth one, the degree of dissociation increases with dilution. That means there is directly proportional between degree of dissociation and dilution. At infinite dilution, dissociation is 100% complete, we can say. Next, fifth point, according to Arrhenius, electrolytes are of two types, students. What are they? Strong electrolytes and weak electrolytes. You know what are these strong electrolytes? Strong electrolytes means they can be completely ionized. Okay, so no question of it's not dissociated or it is partly dissociated. Strong electrolytes are those which can be completely ionized. So when once they are completely ionized, students, you know, they can produce large number of ions. So the number of ions coming from strong electrolytes, it will be in a good number, and when once the ions are greater in number, they can conduct large amount of electricity. Okay, so few examples I have mentioned here, students. First one I have mentioned salts like NaCl, KCl, ZnSO4, strong acids like sulfuric acid, HCl, HNO3, strong bases like sodium hydroxide, KOH, barium hydroxide, etc. And the second type is weak electrolyte, students. This is completely opposite to strong electrolytes. Strong electrolytes are completely ionized, whereas weak electrolytes, they are partially ionized. Part of the weak electrolyte only will be ionized. When once it is partially ionized, the number of ions produced will be less, and when once the number of ions produced are less, they can conduct less amount of electricity. Examples I have given: weak acid, acetic acid, weak base, ammonium hydroxide. This is the fifth point, students. Next, coming to sixth point, the extent of dissociation in strong electrolytes is high and that of weak electrolytes is low. Based on the definition of strong electrolytes and weak electrolytes, we can quote this sixth point, students. The extent of dissociation in strong electrolytes, blindly you can say it is high, and in weak electrolytes it is low. So these are the 6 points under Arrhenius theory of electrolytic dissociation, students. Hope you understood. Okay, and there are few limitations of this theory, students. So first one, under limitations, because when you are asked this question, students, Arrhenius theory of electrolytic dissociation, you just cannot write all the 6 points and just leave the answer. You should mention the limitations also, then only the answer will be complete. Okay, so there are 2 limitations under this theory. First one, if you see, so according to Arrhenius, we have seen that electrolytes dissociate when they are in water, and also degree of dissociation increases with dilution, and they remain unionized in solid state. So the meaning of electrolytes when dissolved in water dissociate into ions means what? In solid state, that means when you don't add water, they are not able to dissociate or they are not able to ionize. Okay, but X-ray studies have proved that many electrolytes are ionized even in solid state. For example, potassium chloride. That is the first limitation of Arrhenius theory. Okay, students. Now, second limitation is, students, Ostwald's dilution law. This is also a very, very important question, students. This is derived from Arrhenius theory, and this Ostwald's dilution law fails when applied to strong electrolytes. See here, you can see strong electrolytes are completely dissociated in solution even at moderate concentrations. So away from the equilibrium between dissociated and undissociated, there is no question of equilibrium. So that's what I have mentioned here. The question of equilibrium does not arise. Why, students? Because strong electrolytes, they are completely dissociated in solution even at moderate concentrations. Okay, so this is the second limitation or defect of Arrhenius theory of electrolytic dissociation. So students, you just when you are asked this question, first you have to define electrolytes, then you should mention all 6 points under Arrhenius theory, and also you should mention 2 limitations or defects of Arrhenius theory. Okay, students, hope you all understood this topic, and please kindly note down all these points in your notebook, and those who are watching for the first time, please try to subscribe the channel, like and share with your friends. Okay, so meet you in the next video, students, with a new topic. Thank you.